I've posted a link to a blog article about Saturable elimination and how the Michaelis-Menten equation relates a drug's concentration to its rate of elimination. In general, it's a good summary of the basic concepts, but the author made quite a serious mistake, which I'm going to point out in this video because I think it serves as a good learning opportunity. The author posted this equation, which says that the Michaelis-Menten equation gives us a drug's clearance at a specific concentration. But this is wrong. What he should have written is that the drug's rate of elimination, that is, the amount of drug eliminated per unit time at a particular concentration, is given to us by the Michaelis-Menten equation. So remember from previous lectures that clearance is not the same as the rate of elimination. Instead, clearance is the proportionality constant that gives us the rate of elimination at a particular drug concentration. So if we want to examine the Michaelis-Menten equation a little more closely, what we can do is rearrange it slightly like this. And then we can see that the term circled in red is what's replacing the clearance parameter from first order kinetics. So if we set clearance equal to that term, we notice that if drug concentrations are very low relative to the Km parameter, the concentration term can be removed because it doesn't have a big influence on the value of the term, and clearance becomes a constant with a value that is directly proportional to Vmax and inversely proportional to Km. That's why when concentrations are below levels that saturate elimination processes, and that is for all practical purposes at concentrations that are about half the value of Km, clearance becomes a constant, and the rate of elimination is, for all intents and purposes, a first order process that is directly proportional to the drug's concentration. On the other hand, if the drug's concentration is close to or higher than Km, it actually starts impacting the value of clearance, and clearance decreases as the drug's concentration increases. So the rate of elimination is no longer proportional to the drug's concentration by a constant factor. That factor is changing as drug concentration changes as well. And when the drug concentration is very high and has saturated the process, Km no longer has much influence on the rate of elimination, which means that elimination becomes constant at a value that is equal to Vmax.